Hello, welcome, happy holidays, and thank you for again zooming into the void with the Danville Science Center, presented by Danakid Associates. I'm Science Ben, Immersive Experiences Coordinator at the Danville Science Center, and your host for our tour of the December night sky for 2021. December, it tends to be a good time for sky watching for a variety of reasons. There's lots to see, lots of planets and other bright objects in our sky this month, and the end of the year also tends to be a time when there are lots of space missions. So let's go ahead and dive into discovery. We begin as we always do here outside of the Digital Dome Theater in the backyard of the Danville Science Center. We are facing the southern sky, and taking a few steps back, we can see to our right the west, to our left the east, making north directly behind us. Gazing skyward, we can see that our sun is hanging low in the sky as it makes its way to its lowest and fastest apparent journey across the sky on the 21st, resulting in the winter solstice, the longest night of the year. If we continue through time to just after the sun has descended past the horizon, we'll say going a little bit further, right around 7 o'clock from our location. Gazing around these telephone poles, we find three particularly bright lights lined up nice and in a line. We call these planets. Of these planets, Venus is the lowest and the brightest, so it will be the easiest to see in tonight's sky, followed by ringed Saturn and the largest planet in our system, Jupiter. All three of these planets will be visible throughout the month and shortly after sunset. As we continue further into the evening and our planets descend past the horizon, we see the bright moon raising in tonight's sky. At 76% illumination, our moon is in the waxing crescent phase. The wash of the moonlight will present a threat to even the brightest stars, many of which we can see in tonight's sky in the winter asterism, seen here to the left of the moon. This contains 6 particularly bright stars, including some of those that make up the familiar constellation Orion the Hunter. And his foot is Rigel, which is part of that winter constellation. Keeping our gaze in this region, you may notice a series of blue dots. These represent the myriad of meteor showers that are currently going on and that will continue to go on throughout the rest of this month. The most exciting of these showers is the most exciting meteor shower we see all year, and it peaked this morning. Fortunately, you can continue to see it tomorrow morning and for a few more weeks if you get up quite early. Radiating out of Gemini the Twins, the Ganymede meteor shower is indeed one of the brightest showers of the year, often producing bold, bright white meteors. It can be spotted in the evening hours, but best seen early morning, around 4 a.m. after the sun has set. From Danville, we can expect 119 meteors an hour. Meteors are space rocks, usually part of larger ones like asteroids or comets. Astronauts often find new space rocks, like Gregory Leonard, who spotted the first comet discovered this year way back in January. Greg spotted what is now being called Comet Leonard, observed from an observatory in Arizona. This retrograde comet has likely been traveling for some 35,000 years from the outer solar system towards the sun. It will reach its closest approach to the sun on January 3rd before melting away forever. This means that Comet Leonard is currently traveling close to Earth. Sunday, it made its closest appearance at just 21 million miles away. By comparison, Venus is 41 million miles away. This means that Comet Leonard should be an easier comet to find, with some sky watchers claiming to have spotted it with just the naked eye. For most of the month, the comet could be found in the east just before sunrise, but tonight, the comet starts appearing in the evening sky for just a little bit after sunset. Look low across the horizon for an object that NASA says looks like a fuzzy star. 21 million miles is relatively close to the Earth. However, Comet Leonard poses no threat to the planet. But what if it did? What if a comet or an asteroid or some other large object were at risk of impact with the Earth? What could we as Earthlings do about it?
In case there was an asteroid coming towards Earth and you're there, you can actually stop it. I mean, that's kind of fantastic.
NASA is crashing a spacecraft into an asteroid.
What? You think science fiction, but this is real. Never in my life would I have thought I would take a couple $100 million spacecraft and crash it into an asteroid. My name is Michelle Chen.
I'm Lena Adams.
My name is Kelly Fast.
I'm Andy Rifkin.
I'm Justina Sorovitz, and I help tell the story of the DART mission.
I'm a planetary defender.
And I study how the orbits of asteroids change after we hit them with spacecraft.
My job was primarily to make sure all the systems on the spacecraft work together.
The DART mission is NASA's first test of a planetary defense technique called kinetic impactor.
DART is the double asteroid redirection test.
It's just a spacecraft that is going to go and smack an asteroid.
The moonlet Dimorphos, which orbits the asteroid Didymos,
And see if we can change its trajectory just a little bit.
in order to show that we can deflect incoming asteroids if we need to.
DART will only be changing the period of the orbit of Dimorphos by a tiny amount.
But in space, just a little bit is just enough to make an asteroid actually miss us.
In the event that an asteroid is discovered well ahead of time before it might impact Earth.
Behind me, you see the spacecraft.
It's really cool to see it coming together in real life.
It is fantastic to see it in real life.
To see it turn from ideas into real pieces that are gonna go into space.
The solar arrays will actually roll out to 28 feet in length.
Once the solar arrays are deployed, it's going to be the size of a school bus. As the solar array opens out, it's going to swing out in this direction. The asteroid's only 2 football fields in size.
We're flying at over 6 kilometers a second.
30 days out, we see 1 pixel on our field of view.
You can see Didymos and Dimorphos as one point of light.
About 4 hours out, our spacecraft becomes autonomous.
And then that's where everything gets really exciting.
You actually are seeing impact.
We're super excited and nervous as well.
I feel really honored and humbled to be working in an area of science that has such a broader impact, figuratively and literally.
No DART! The dinosaurs are made completely extinct by an asteroid impact so many years ago. Here we are, we can actually do something about it. I think this is just wonderful.
DART will not blow up Dimorphos. Just push it a little. Actual planetary defense is less like the movie Armageddon Day and more like the movie The Blind Side. 'Cause he was an offensive lineman. If all goes well, the DART spacecraft will impact with Dimorphos in September of next year. So that's one way we could avoid cosmic collision. That's by pushing the object out of the way. But what if we could just move? Well, we can't move the planet, but there are other objects in space, like satellites, telescopes, and the International Space Station, that all have to make adjustments to their trajectory over time. Rocket fuel is too heavy and expensive to accomplish this with jet bursts, so instead, NASA's spacecraft use gyroscopes. At its most basic, a gyroscope is a spinning disk in which the axis of rotation is free to assume any orientation by itself. They are used to orient and maintain angular velocity. You may have felt the effects of angular velocity if you own one of these. After setting the disk spinning, if I alter its axis of rotation, I can feel resistance. I can feel a force acting against that movement. If I had a large enough spinning disk and altered its axis of rotation, its angular velocity would transfer to me, and in the absence of friction, I'd start to move. Orbiting spacecraft use this principle and gyroscopes to make slight adjustments in their travels. Speaking of orbit and space telescopes, the James Webb Space Telescope will finally launch into orbit one day after the winter solstice, next Wednesday, December the 22nd. The successor to the Hubble Space Telescope, James Webb is capable of advanced infrared vision, allowing scientists to peer not just further into space, but farther back in time. You can follow a countdown to launch to learn everything you've ever wanted about the telescope by visiting jwst.nasa.gov. James Webb will park at Lagrange Point 2, placing it far enough out of orbit of nearby planets and moons to prevent it from falling into them, but also close enough to prevent it from drifting out into space. To learn more genuinely about space and the cosmos, you can get a response from your local informal astronomer, me. Feel free to submit your queries to Science Bin via the Science Center's Facebook page, and we may just respond on air. This month's question comes from Judy B, who asks, why are the stars and moons so bright? I have been watching the sky for the last little while and they seem brighter than usual. Well, Mrs. B, colder winter air holds less moisture than warm air. Humid summer months can produce a hazy sky, but the winter months literally have clearer air for stargazing. There are also several planets currently positioned for keen viewing, providing more light, in addition to the usual prevalence of first magnitude stars this time of year. Rigel, fiery red Aldebaran, Capella, Pollux, Procyon, Sirius, and Betelgeuse are all above the horizon, hanging out in that winter hexagon, in that winter circle. So there are lots of bright things to see in a particularly clear sky, making this time of year a great time to look up. Thanks, Ms. B, for sending in your question. We are very grateful. As 2021 comes to a close, we are also grateful for you joining us for a year of interstellar discussion. We look forward to more in 2022 when we can keep up the conversation the second Tuesday of every month at noon. Until we meet again on January the 11th, we wish you a happy holiday season and a curious new year. Goodbye.